For the scenario where there is a 400 amp meter with two 200 amp panels fed by 3/0 copper conductors, let's consider the grounding requirements. Firstly, let's address the situation where a number 2 copper ground wire comes out of the customer-owned meter box to the water pipe and building steel, adhering to the 5-foot rule. It is likely that this will pass inspection. According to the 5-foot rule, a common requirement in the National Electrical Code, if the grounding electrode conductor is connected to the water pipe and the building steel within 5 feet of where the grounding electrode conductor enters the building, then the grounding electrode conductor size can be reduced to the next smaller trade size. In this case, with a 400 amp service, a 3/0 copper grounding electrode conductor is typically required. Reducing the grounding electrode conductor size to number 2 copper within 5 feet of entry is generally acceptable, given compliance with the specific requirements outlined in NEC section 250.66. Now, secondly, consider the situation where the number 2 copper ground wire comes from only one panel to the water and steel. It is unlikely that this will pass inspection. The NEC requires that the grounding electrode conductor be connected to the grounding electrode system at each service disconnecting means. In this scenario, there are two 200 amp panels, indicating that there should be 2 separate grounding electrode conductors, each connected to the grounding electrode system. Connecting the grounding electrode conductor from only one panel to the water and steel would not meet this requirement. To elaborate further, grounding electrode conductors play a crucial role in providing a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. This is essential for electrical safety, as it helps to quickly clear faults and minimize the risk of electrical shock or fire. The NEC provides detailed guidelines on the sizing and installation of grounding electrode conductors to ensure that they are capable of effectively carrying fault current. NEC section 250 covers the requirements for grounding and bonding, and it is important to consult this section to ensure compliance with the code. The size of the grounding electrode conductor is determined by the size of the service entrance conductors or the equivalent area for parallel conductors. Table 250.66 in the NEC provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For example, if the service entrance conductors are 3/0 copper, the minimum size of the grounding electrode conductor is typically number 2 copper. However, as mentioned earlier, the 5-foot rule allows for a reduction in the size of the grounding electrode conductor under certain conditions. Specifically, if the grounding electrode conductor is connected to the water pipe and the building steel within 5 feet of where it enters the building, the size of the grounding electrode conductor can be reduced to the next smaller trade size. This is because the water pipe and the building steel provide a supplementary grounding path which reduces the impedance of the grounding system. However, it is important to note that the 5-foot rule only applies if the grounding electrode conductor is connected to both the water pipe and the building steel. If the grounding electrode conductor is only connected to one of these electrodes, the full-size grounding electrode conductor is required. In the case of multiple service disconnecting means, such as the two 200 amp panels in this scenario, each service disconnecting means must have its own grounding electrode conductor connected to the grounding electrode system. This is because each service disconnecting means is considered a separate service, and each service must have its own grounding system to ensure electrical safety. The grounding electrode system typically consists of a combination of electrodes, such as a metal underground water pipe, a building steel, a ground ring, or ground rods. The NEC specifies the requirements for these electrodes and the methods for connecting them to the grounding electrode conductor. It is important to ensure that the grounding electrode system is properly installed and maintained to provide an effective grounding path. In addition to the grounding electrode conductor, bonding jumpers are also required to connect various metal parts of the electrical system together. Bonding jumpers are used to ensure that all metal parts are at the same electrical potential, which minimizes the risk of electrical shock. The NEC provides detailed guidelines on the sizing and installation of bonding jumpers. Overall, Grounding and bonding are critical aspects of electrical safety, and it is important to understand the NEC requirements for these systems. Proper grounding and bonding can help to prevent electrical shock, fire, and other electrical hazards. Now let's delve deeper into the specifics of grounding electrode conductor sizing and installation, referencing relevant sections of the National Electrical Code for clarity. According to NEC Section 250.24, for grounded systems, the grounding electrode conductor connection shall be made at any accessible point from the load end of the service drop or service lateral tube and including the terminal or bus to which the grounded conductor is connected to the service equipment. This means that the grounding electrode conductor must be connected to the grounded conductor, typically the neutral, at the service equipment, ensuring a direct path for fault current to return to the source. Furthermore, NEC Section 250.64 outlines the requirements for grounding electrode conductor installation. It states that the grounding electrode conductor shall be installed in one continuous length without splices or joints, unless spliced only by irreversible compression type connectors listed as grounding and bonding equipment or by the exothermic welding process. This ensures the integrity of the grounding path and prevents any potential points of failure. NEC Section 250.66 provides the requirements for sizing the grounding electrode conductor. As mentioned earlier, the size of the grounding electrode conductor is determined by the size of the service entrance conductors. Table 250.66 provides the minimum size of the grounding electrode conductor for various sizes of service entrance conductors. For example, if the service entrance conductors are 3/0 copper, the minimum size of the grounding electrode conductor is typically number 2 copper. However, it is important to note that the table provides minimum sizes, and a larger grounding electrode conductor may be required in certain situations, such as when the grounding electrode conductor is serving multiple buildings or structures. The 5-foot rule, as previously discussed, is an exception to the general sizing requirements for grounding electrode conductors. NEC Section 250.66 states that if the grounding electrode conductor is connected to the grounding electrode system, which includes a metal water pipe electrode and a building steel electrode, within 5 feet of the point of entrance to the building, the grounding electrode conductor size can be reduced to the next smaller trade size. However, this reduction is only permitted if the grounding electrode conductor is connected to both the metal water pipe electrode and the building steel electrode. If the grounding electrode conductor is only connected to one of these electrodes, the full-size grounding electrode conductor is required. In the case of multiple service disconnecting means, NEC Section 250.64d requires that each service disconnecting means have its own grounding electrode conductor connected to the grounding electrode system. This ensures that each service has its own grounding path, providing redundancy and enhancing electrical safety. The grounding electrode system, as defined in NEC Section 250.50, consists of all available electrodes, including metal underground water pipes, building steel, ground rings, and ground rods. The NEC specifies the requirements for these electrodes and the methods for connecting them to the grounding electrode conductor. Metal underground water pipes, if available, are generally considered the primary grounding electrode. NEC Section 250.52a outlines the requirements for metal underground water pipes used as grounding electrodes. The water pipe must be in direct contact with the earth for at least 10 feet, and it must be electrically continuous. Building steel, if available, is also a commonly used grounding electrode. NEC Section 250.52 at WO specifies the requirements for building steel used as a grounding electrode. The building steel must be electrically connected to the earth, and it must be reliably interconnected to form a continuous grounding path. Ground rings, as described in NEC Section 250.52 are another type of grounding electrode. A ground ring is a bare copper conductor that is encircling the building or structure and buried directly in the earth at a depth of at least 2.5 feet. Ground rods, as specified in NEC Section 250.53g, are often used as supplementary grounding electrodes. Ground rods must be at least 8 feet in length, and they must be driven into the earth to a depth of at least 8 feet. When multiple ground rods are used, they must be spaced at least 6 feet apart. In addition to the grounding electrode conductor, bonding jumpers are also an essential part of the grounding and bonding system. Bonding jumpers are used to connect various metal parts of the electrical system together, ensuring that all metal parts are at the same electrical potential. This minimizes the risk of electrical shock. NEC Section 250.92 outlines the requirements for bonding service equipment. It requires that all service equipment, including meter enclosures, service disconnects, and panel boards, be bonded together using bonding jumpers. NEC Section 250.94 specifies the requirements for bonding metal water piping systems. It requires that metal water piping systems be bonded to the grounding electrode system to ensure that the water pipes are at the same electrical potential as the earth. NEC Section 250.96 outlines the requirements for bonding other metal parts, such as metal raceways, metal enclosures, and metal equipment. It requires that these metal parts be bonded together to create a continuous grounding path. Proper grounding and bonding are critical for electrical safety, and it is essential to comply with the NEC requirements for these systems. By following the NEC guidelines, electrical professionals can help to prevent electrical shock, fire, and other electrical hazards. Remember to consult the latest edition of the National Electrical Code for the most up-to-date requirements and to seek guidance from qualified electrical professionals when designing and installing electrical systems. The information provided here is for general knowledge and informational purposes only, and does not constitute professional advice. It is essential to consult with a qualified electrician or electrical engineer for specific advice related to your particular situation. The National Electrical Code is a complex and comprehensive document, and it is important to have a thorough understanding of the code before undertaking any electrical work. Electrical work can be dangerous, and it is essential to take all necessary precautions to ensure your safety and the safety of others. Always to energize electrical circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to do the work for you. By following these guidelines, you can help to ensure the safe and reliable operation of your electrical system. Finally, remember that electrical codes and regulations can vary depending on your location. It is important to check with your local authorities to determine the specific requirements for your area. Compliance with local codes and regulations is essential for ensuring the safety and legality of your electrical installations. Always obtain the necessary permits and inspections before undertaking any electrical work. This will help to ensure that your work is done safely and in accordance with the applicable codes and regulations. By taking these steps, you can help to protect yourself, your property, and the community from electrical hazards.